Okay, so Common Core, right? Not that you guys care about the Common Core, but my boss does because I'm supposed to be teaching you the Common Core. So the Common Core standard is today, it is an F for function, then an I, F, E, and then it's inequalities we're going to be doing. And it's basically doing quadratic inequalities. Okay, so example 1. We want to graph this, right? Vertex, line of symmetry, y-intercept, x-intercept. So let's do all that. And then we're actually going to let the calculator give us what the shape looks like, okay? So right off the bat, first of all, vertex. Now, again, vertex is negative b over 2a. We're going to need that, okay? So I'm going to go, all right, a negative 4 over a 2 times a negative 2, okay? Negative b over 2a will give us the vertex. And that is a 4 over negative 4, right? We get a 4 over negative 4, but that's just a negative 1. Now, negative 1 is something, right? So we're going to have a coordinate of a point at negative 1 something. So I did my negative b, which is a negative 4, over 2a, which is 2 times negative 2. And I got negative 1. Negative 1 something. So to get something, I got to plug that in. I'm going to go, okay, negative 2 times my negative 1 squared minus my 4 times my negative 1 plus 6. And, you know, I do believe in the calculus. I really do. Because, you know, I could do this by hand. Or why not just let the calculator do it for you? Let technology be my friend, okay? So I would go negative 2 parentheses. I'll go negative 1 squared, right? Minus 4 times my negative 1 plus 6, okay? Right? Just let the calculator put it in exactly like that. I got 2 times negative 1 squared. Subtract 4 times. Now there's a difference on the calculator between negative and subtract, right? And it's a different button too. One button is the subtract button, the other button is a negative button. So I push enter and I get 8, okay? So my vertex is at negative 1, 8. I can graph that, right? Negative 1, 1, 2, 3, 4, 5, 6, 7, 8, okay? I sure will, yeah. There it is.
I got it now.
You got it? Okay, good. And then, so now my y-intercept, that's pretty easy. That's when x equals 0. So if x equals 0, then you take a look at the equation, right? That's 0. And that's 0. So you'd just be left with 6. The y-intercept is that number, okay? That is the y-intercept. The y-intercept is that number, 0, 6, okay? Has to be that number because if x is 0, all you'd be left with is 6, right? So 1, 2, 3, 4, 5, 6, okay? Now, I know there's another point over here. I know there's another point here. Has to be, right? Has to be another point here because if that's the vertex, there's a line of symmetry, so I can fold it over, okay? I can even put the line of symmetry in there if I wanted to. The line of symmetry just kind of goes like this, right? How am I doing, okay? All right? Yes, Will.
Is it 2 down?
It is 2 down because of the
It's
2.
2.
Yes, you're totally right. Will, 100% correct, okay? Now, how about x-intercepts? Well, if I set it equal to 0, negative 2x squared minus 4x plus 6, right? Then either I'm going to have to use, the quadratic formula or it factors. And I don't know if this will factor, but first, before I do anything, I really don't like that negative 2. In fact, I hate to factor with a number here, right? And if I can divide it out, I will. So if I divide everything by negative 2, let's see if it makes it any easier for me. I get an x squared minus a 2x plus a 3, right? Oh, I'm wrong. Positive 2x minus 3. I am so sorry. Divide by a negative. I forgot to turn the signs, didn't I? I got an x squared positive. So I think it'll factor. Now, Jackson, you can use the quadratic formula. 80, you guys can use the quadratic formula. For me, boy, if I could factor it, it makes it so much easier. X, right? And I'm going to get a positive 3 and a negative 1, right? If I factor it, so much easier to factor, right? So then I get x equals negative 3. So one of my x-intercepts is at negative 3, 0, which is here, right? My other x-intercept is at 1, 0, okay, which is right there, okay? Now, pretty much have it. Yeah, Will?
Can't you also just graph it?
I could, yeah. Okay. So, and I'm going to answer that question, okay? Okay, there it is, okay? Now, There's only one thing I got to deal with, and that is this symbol right there. You see that symbol? Less than. Now let's use a little common sense. Less than probably means below, right? Do you agree with that? So below's got to be below the parabola. So I think I'm probably going to shade everything below the parabola, which would be inside of it, wouldn't it? Okay. I could test a point. So to test a point, I could pick any point in that blue region, any point to test it to see if actually I shaded the right region. And the easiest point to pick, I can pick any point, but what do you think is the easiest point to test? Yeah. Not the vertex. No, not the vertex, but the... What's the easiest point to pick? How about 0, 0?
Oh, yeah.
Wouldn't 0, 0 be the easiest point?
Yeah.
So why don't I test it with 0, 0? So I got point 0, 0. Let's test it. So put 0 in for y. Okay, so I'm going to go 0 is less than or equal to negative 2 times 0 squared minus 4 times 0 plus 6. I get 0 is less than or equal to 6, right? 0, 0. Is that true? Is 0 less than or equal to 6? Yeah, so I shaded the right region. I already knew I had. So I test the point. Yeah, yeah. I plugged in 0, 0. I got a true statement. I already knew it was the right answer. I knew it. Now, how about the calculus, okay? Calculus also shade. They also shade.
What?
They also shade. These things are so cool. So, you ready? You're going to love this. Okay? Y equals, right? Okay. Okay, I want you to shift it all the way. What I did is I took my back and forth arrow, see my back and forth arrow? See this back and forth arrow? I put it right there, okay? Okay, now this is a little symbol of my calculator that tells me what kind of line I want to draw. Right now it's drawing a straight solid line, okay? All right, push enter. Now it's going to draw a heavy line. Okay, enter again. Now it's going to shade greater than. It's going to shade greater. See how it's got a dark triangle on the up the upper half? Enter, that's going to shade less than, right? Isn't that cool? What do I want? I want less than, don't I? So I want to go y is less than a negative 2x squared. Subtract 4x plus 6. Okay, put that in there. Now, because I've got my little darkened half triangle, it's going to shade less than. Does that make sense? Okay, so you ready? Check it out. You guys ready?
Ready. Oh,
That's pretty cool.
I like that.
Is that what I have on my graph?
Yeah.
I do, don't I?
Yeah.
Yeah.
It's not super shady.
Well, it's not super shaded, but you know, that's okay. It certainly helps me though, doesn't it, right? Isn't that easy? Thumbs up?
Yeah.
Good, I'll wait for you, Evie. Yeah, anybody need help? Anybody need help?
Negative 2.
Oh, I know how to make it like
Mine
equal.
nothing
Oh,
was
probably.
happening when I pressed y equals. My calculator wasn't.
I love playing
Why is there anything happening? I didn't even turn my calculator. Jesus.
Or and talk about it. Oh, is this the Oh, I can't understand.
Some days it's not.
Well, aren't you fancy? Just hand in your calculator. Show me what you do.
Just like 26. I didn't even.
Oh, I didn't square it.
Yeah. What's the equation?
I didn't square it, that's why.
Let's do x squared plus 1 equals 6.
This one. Yeah.
My calculator. It worked. What is yours? Well, yeah, it's square. Look how close I Hi guys, yes. Oh my God.
Oh, that's why I didn't do it.
When do I want? Okay, real quick, you guys. Some of you guys are. You got to go back real quick. Shh, you got to go back to your window, okay? Let's go back to my window, okay? So my window is negative 10 to 10, because I'm just doing a normal graph, right? So negative 10 on my x to 10 scales by 1. So I've got my negative 10 to 10 scales by 1, and then negative 10 to 10 on the y's, right? And scales by 1, okay? So when you do that, you should get closer, okay? Okay, I'm coming around. Anybody else need help? Yeah. There's my. Okay, so you ready? This is your x.
So now your graph.
Beautiful.
Mine's all the same, right?
Anybody else? Anybody else? That's what
It's because you're lying. And then you.
What is?
No, I said no battery.
still be going down.
Yeah, but that's so the same. You can't see. It's basically.
Okay, everybody good? Okay, everybody good?
All right. So, got it. Graph. Everybody good? Did I get to everybody? So before I stop, shh, 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 shh. Listen. Okay, real quick. Okay, now listen. So the calculators can be awesome, but your window. Let's go back to the window. If I look at the graph itself, it can help me with window. In fact, I could do, watch, on my window, I could do really negative 5 to 5, couldn't I? I could, right? And I could go like maybe negative 8 to whatever, right? But a standard window, negative 10 to 10, always works, okay? All right. Now, let's take a look at example 2. You guys ready for example 2? Everybody okay on the first example, right? Let's go to example 2. And example 2 does not have a y. So you cannot graph it. Does that make sense? You can't graph number 2. It does not have a y. So we're going to have to do some things the old-fashioned way, okay? So first of all, let's go minus 3, minus 3. So we set it equal to 0. Set equal to 0, okay? That's the first thing I want to do. Set it equal to 0, okay? So I'm going to have an x squared minus a 6x plus 5 equals 0, okay? That's the first thing I want to do. Set it equal to 0, okay? I want to factor it. So I'm going to factor. So if I factor this, I'm going to go parentheses, 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 x and x. Okay, now, what times what makes 5? It's not a trick question. What times what makes 5? Austin?
Negative 1 and negative 5.
It's going to be 5 and 1, but more specifically, negative 1, negative 5. Now, Austin said negative 1 and negative 5. Why do you make them both negative?
So you can get a negative 6.
When you multiply them, we'll get the positive 5, but when you add them, you get the negative 6. Do you see? Remember the double smiley? Yes, this one we have to factor. If we multiply them, we'll get the positive 5, but if we add them, like our double smiley, we'll get a negative 6, okay? Okay, does that make sense? So then, these are what we call border points, because we're going to put this one on a number line, okay? So what we call border points. So my border points are x equals 1 and x equals 5. Because when I solve for it, right, solve +1 + 1, solve +5 + 5, right? So these are my border points. Now this one has to be on a number line because there's no y variable. So okay, I'm going to go to a number line, scratch out a number line. I'm going to put a 1 and a 5. And for me personally, I do not need all the other numbers in between. Okay, I know you know where all the other numbers are. So if you want to put all the little dashes in, fine. Okay, but we don't need them all in. Okay. Now, real quick question. There's no little equal sign here. So I'm going to have an open circle at my border points. If there were a equal sign, I'd do a closed circle at my border points because it can equal that value, or it can equal that value, but these have to be less than my values. They can't be equal to my values, so it's open circle, because there's no equal sign. If there were an equal sign, I'd go solid dot, okay? Equal sign, solid dot, no equal sign, open dot, Capiche? Now, where do I graph? Well, let's test a point. You've got 3 regions, right? What's the easiest point to pick? You've got a region here, here, or here, right? Let's take 0. Let's test 0, okay? So if I test 0, plug 0 to my original. I'm going to test 0, and I put 0 in. So I'll test over here. So let me do my test over here because I'm running out of room. I'll go 0 squared minus 6 times 0 plus 8 is less than 3. Okay, so I just plugged in my 0 because I'm testing my point. So I really get 8 is less than 3. Is that true? So don't shade that region. Shade the next region. Shade this region. Now I can test this. Give me a number in here.
We can't see it.
Yeah. So give me a number in here. I'm going to test this one. Give me a number in here. Okay, 3. Let's test 3, okay? So I'm going to use my calculator, and I'm going to go, okay, I'm going to go 3 squared minus 6 times 3 plus 8, and I get -1. Is -1 less than 3? Is negative? Yeah, so I have to shade this region, right? Okay, let's check this region. Give me a number in this region.
8.
8. Let's test, okay? Let's go 8 squared minus 6 times 8 plus 8, and I get an answer of 24. Is 24 less than 3?
No.
So don't shade this region, okay? Now, that's our number line. Can we put that in interval notation? Sure we can. Parentheses 1, 5. Now it looks like a point, but it's not a point. It's an interval. It's an interval. It's saying go from 1 to 5. Shade from 1 to 5. Why are there parentheses? Why are there parentheses? Open circles. If they were solid dots, I'd do the bracket. Remember that? Okay, how about example number 3? Same thing. All right? So for me, I'm going to set equal to 0, okay? All right, so I'm going to bring over the 1, so I'm going to have to subtract the 1, subtract 1. Get a 2x squared minus a 5x. That just disappears, doesn't it? Is greater than or equal to 0, okay? How am I doing, okay? Factor. Now, you guys don't like this kind of factoring, but it's the easiest of all. This is a factor. You always forget how to factor this one, but this is the easiest one of all. We're going to common factor. They only have one. What do they have in common? Just an x. They have an x in common, so I take out the x. And what's left over is a 2x minus 5. Okay, I'm looking for border points because I'm going to do a number line because there's no y, okay? So if we do border points, I'm going to have, all right, x equals 0 and 2x minus 5 equals 0. Okay, that's no problem. X equals 0, that is an answer. That's a border point on my number line. So I'm going to go to my number line. And at 0, I'm going to put a solid dot because there's a little equal sign, okay? And my other border point, plus 5, right? Divide by 2, and I get 2.5, okay? So I solve 1 plus 5, right? Plus 5, I got 5. Divide by 2, I get 2.5. So I'm going to put 2.5 on my, okay, boom. Now, where am I going to shade? Let me test some regions. I got 1, 2, 3 regions. See them? So let's test them again. Let's use the calculator. Doggone it. So let me test. So give me any number over here. Any number. -1. Let's plug -1. So I'm going to go 2 times -1 squared. Subtract 5 times -1 plus 1. I get an answer of 8. Is 8 greater than 1? Yeah, so I wanna shade that region, don't I? Okay. Okay, give me a value in here. No, in here. How about 1? Okay. So let's test 1. Okay, I'm going to go 2 times 1 squared minus 5 times 1 plus 1. I get -2. Is -2 greater than or equal to 1? Is -2 bigger than 1? No, so don't shade that region, right? That's not true. Give me, okay, now, Will, give me a region, give me a number in here, okay? 4 sounds great. Let's use 4, okay? So I'm going to go 2 times 4 squared, subtract 5 times 4, plus 1. Boom, I get 13. Is 13 bigger than 1? Yeah, so let's shade that region, okay? How's that look? Interval notation. Well, what's the very last number? Yes, Jackson. Okay, what's the very last number here? What's the very last number here? It's -infinity, isn't it? So parentheses, -infinity, comma 0, bracket. Or, and I'm going to use this symbol, union means the same thing as or, union, with bracket 2.5, comma, infinity, parentheses, okay?
I'll be back for track, but I guess that's going a little bit.
Okay, Aaron, question. What's that? Almost, because I'm almost done, okay? Turn the page, and I'm not going to do the story problem just simply because we're going to run out of time. So, here's what I want, okay? Page 373 to 17 odd and 74.